Hello everyone, my name is Sudhanshu Kumar. Today I am going to mm, answer 15 machine learning problem provided in week 6 assignment. The first question is, what is hyperparameter? Give some example. What is hyperparameter tuning? Hyperparameter basically a tuning fork which is used to control the learning process, and it is provided before the model to learn, and its value is not affected by the data. Various type of hyperparameter, that is learning rate, batch size, number of epoch, and n estimators. And what is hyperparameter tuning? It is basically a set of parameter provided to model to learn for a learning algorithm, and it basically apply to a model to optimize the result. There are two types of hyperparameter, that is grid search CV and randomized search CV. In grid search CV, we create grid between different set of hyperparameter and select best one of them which provide maximum accuracy in the model. In randomized search CV, we create random combination of hyperparameter and select those those parameter which gives maximum accuracy. When comparing these two method, that is grid search CV and randomized search CV, we can say that grid search CV take more time as compared to randomized search CV. How would you evaluate an unsupervised learning project? In unsupervised learning, we have unlabeled data. Hence, we have check we have to check the within cluster. There is a similarity between different data or feature, and we at the same time we have to check the dissimilarity between the two features. Means dissimilarity between two clusters. There are several metrics we use for supervised learning, that is Silhouette index, adjusted rand index, Jaccard score, Dan index. If you move the classification threshold from 0.3 to 0.5, will precision or recall increases or decreases, and why? If we increase the threshold from 0.3 to 0.5, it means that its precision increases but recall decreases. If we decrease the value, that is below 0.3, then recall increases and precision decreases. What is the difference between test set and validation set? Why validation set is required? Test set is used to check the performance of the model, and validation set is used to tune the parameter of a classifier. Why validation set is required? Validation set, when we train a model, we try different combination of hyperparameter. For that, we need some validation data. Hence, we need validation data. Hence, validation set is required. It is basically a portion of trained data set. Suppose I have a 10 data set which contains 10,000 rows. We consider 20% of the whole data as a test data and remaining as a trained data. By this way, we can say that 8,000 record is our train set and 2,000 record is our test set. On training data, we perform various cross-validation technique. In this case, we consider k-fold cross-validation, where here in this case we consider cross-validation value is 5. In this case, we validation set is 1600 and train set becomes 6400. We use different combination of hyperparameter and train with this training set which is around 6400, and check their accuracy with their validation set. And finally, predict the output. How do you find the right threshold for classification problem? It basically depends upon business use case. We can say that using precision recall curve for various decision threshold, we can select best value for decision threshold such that it gives high precision without affecting the recall, or high recall without affecting the precision. And explain the sum regularization technique in brief. Regularization is used to reduce the overfitting, and at the same time it reduces the loss. There are two types of regularization, that is L1 regularization, which is also called lasso regularization. It add the absolute value of weight of loss function, uh, weight absolute value of weight to the loss function, and it is also used in feature selection. L2 regularization is also called ridge regression or ridge regularization. It adds the square of magnitude of weight to the loss function. Explain bagging and boosting. Both bagging and boosting are good ensemble method. In bagging, it is also called bootstrap aggregation, and it is also called parallel learning algorithm. It is used to reduce the variance in the model. In bagging, we train different model separately, and if it is a classification problem, then final outcome is based on voting majority, and if it is a regression problem, then final outcome is based on mean of the output of the each model. In uh, now second one is boosting. It is a sequential learning. In this case, shortcoming of the current model is overcome by the next model, and shortcoming of the next model is again overcome by next model. By this way, we can convert the weak base learner into a strong one. What is the difference between Euclidean distance and Manhattan distance? In Euclidean distance, we basically calculate the shortest distance, that is displacement. It uses simple Pythagoras theorem. Suppose we have to reach we have it we have to reach from point A to B via C, then total displacement total displacement, or we can say the shortest distance AB, can be written as root under AC square plus BC square. But in case of Manhattan distance, it basically calculates the path length, that is AB plus BC. Explain the functioning of K-NN algorithm, why it is referred as lazy learner. K-NN algorithm stands for k nearest neighbor, and it is mostly for classification problem. In K-NN algorithm, K indicates the number of nearest neighbor, and it always it is LO method is used to find the optimum value of K. And while selecting the value of K, we always consider K value as an odd number, because it overcomes the situation of tie when two class tie between the classes, so that we can easily predict which class belongs to. And why it is referred as lazy learner? Because in K-NN algorithm, at the time of training, it memorizes the data, and at the end of training, it basically learn the training data and then predict the final outcome. By this way, its process becomes slow, hence it is called lazy learner. What do you mean by model explainability? How would you introduce explainability to a black box model? Modal explainability is helpful in black box model to show the or we can say that we can provide the transparency to the black box model. In this case, we provide the user to what happens in our model from input to output. Model explainability is a degree to which human can understand the cause of decision and decision to which human can consistently predict the machine learning model result. There are various methods to introduce the explainability in the black box model, that is Shapley analysis, LIME, which is also called local interpretable model agnostic explanation, LE5, explain like I am 5 and leave one feature out. How do you evaluate regression problem? What is the difference between R2 and adjusted R2? In regression problem, our output is numerical. Hence, for people who are not aware of machine learning algorithm, and we have to show the comparative study between two model, then you have to show their evaluation matrix like r r square or adjusted r square, root mean square error, or mean square error, or mean absolute error. What is the difference between r square and adjusted r square? R square measures the portion of variation in our independent variable explained by all of our independent variable in the model. It assumes that every independent variable in the model help to explain the variation in the dependent variable. Adjusted R square basically penalize us for adding independent variable that do not help in predicting the dependent variable. It measures the portion of variation explained by only those independent variable that help in explaining the dependent variable. Suppose we have a data set of house price range prediction, and we train the model. We get certain value of R2 score and certain value adjusted R2 square. But if we add a new feature called age in that data set and then calculate the accuracy of the model, as we all know that age is not a significant feature for house price range prediction, but when we add the R square value, then its value increases again. Still it is not a significant feature, but still its value R2 value is increases. But in adjusted R square, it basically penalizes this insignificant feature, and adjusted R square value either decreases or constant, but its value will not increase. What is the difference between machine learning and deep learning? Machine learning is a superset of deep learning. In machine learning, we require more human intervention, and in deep learning, we require less human intervention. Machine learning requires structured data, and while deep learning requires large volume of unstructured data. Or we can say that machine learning can handle structured data, while deep learning can handle large volume of unstructured data. Machine learning we use in daily life like email spam filtering, or we can say the bank fraud detection and medical science or medical research, while deep learning used in robotics field like self-driving car, robot that perform advanced surgery. What is the difference between ADA boost, gradient boost, and ADA boost? In ADA boost, and it is an additive model where shortcoming of the previous model are identified by high weight data point, whereas in gradient boost, shortcoming are identified by its gradient. In ADA boost, trees are usually grown as a stump that is depth of one, or we can say that only one node. And in gradient boost, trees are grown to a greater depth, usually ranging from 8 to 32 terminal nodes. In gradient boost, in ADA boost, each classifier had different weight assigned to final prediction based on its performance. But in gradient boost, all classifiers are weighted equally, and their predictive capacity is restricted with learning rate to increase the accuracy. In ADA boost, it gives weight to both classifier and observation, thus capturing the maximum variance in the data. In gradient boost, it builds a tree on previous classifier, thus capturing the variance in the data. What is vanishing gradient and exploding gradient? In the process of backpropagation, as we move from output layer to input layer, the gradient tends to decrease and it is zero at the input layer. It means that input layer is not changed, or we can say that unchanged. As a result, gradient descent never converges to optimum, and this is known as vanishing gradient problem. In exploding gradient, gradients keep on increasing larger and larger, and it causes very large weight update and cause gradient descent to diverge. This process is known as exploding gradient problem. What is the difference between NN and CNN? Why CNN is used for image processing? CNN is commonly used for spatial data like image, while RNN is used for sequential data like text, text data, or video. CNN uses feed-forward neural network that uses filter and pooling layer, whereas RNN uses feed result back to the network. In CNN, size of input and resulting output is fixed, while in RNN it is variable. In CNN, we can use it for facial recognition, medical analysis, and classification, whereas RNN used for text translation, natural language processing, and sentiment analysis and speech analysis. The main advantage of CNN is it automatically detects important features without any human intervention. So, convolutional layer used in here are capable of reducing high dimensionality of image without losing valuable information. That is why it is widely used in image processing. Thank you.